In this video, we will do some College Board multiple choice questions pertaining to sinusoidal functions. These are functions that can be represented by sine or cosine. This is AP Precalculus Topic 3.5. If you appreciate this content, please give it a like. Number 1. The daily high temperatures of a certain city over a period of time are modeled with a sinusoidal function in the xy plane. The maximum daily high temperature is 80 degrees Fahrenheit, and the minimum daily high temperature is 55 degrees Fahrenheit. Based on these temperatures, which of the following is the best value for the amplitude of the sinusoidal function? Quick side lesson. Here's an example of a sinusoidal function. The line halfway between the highest value and the lowest value is called the midline. Given a graph, it's easy to see that the midline is y equals 1. However, if we didn't have a graph, we could still find the midline by taking the average of the max and min. In this case, 3 plus negative 1 divided by 2. That's 3 minus 1, which is 2, divided by 2 gives you 1. The amplitude is the maximum value minus the midline. In this case, 3 minus 1, which is 2. So for problem number 1, we can find the midline by taking the average of the max and min. That will be 80 plus 55 divided by 2. That's 135 halves. Or you could do 135 divided by 2 and put 67.5. Our goal is to find the amplitude, which is the maximum value minus the midline. So the amplitude will be 80 minus 67.5. That's 12.5. So the answer is A. Number 2. The functions f and g are given by f of x equals cosine x and g of x equals sine x. In the xy plane, for how much of the interval from 0 to 8 pi are the graphs of f and g both concave up? My strategy will be to answer the question for the interval from 0 to 2 pi, and then the answer for the interval from 0 to 8 pi will be 4 times that. The period for both sine and cosine is 2 pi. I've divided that period into 4 equal parts, so each one of these spaces represents a quarter of the period, which is pi over 2. We have memorized that the cosine function looks like this. And we have memorized that the sine function looks like this. The cosine function is concave up on this interval, and the sine function is concave up on this interval. Both functions are concave up on the interval from pi to 3 pi over 2. That's 1/4 of the period, which is pi over 2 radians. On the interval from 0 to 2 pi, both functions are concave up for pi over 2 radians. So on the interval from 0 to 8 pi, both functions would be concave up for 2 pi radians. So the answer is D. Number 3. The figure shows the graph of the periodic function f in the xy plane. What is the frequency of f? In previous videos, I have taught you that frequency is the reciprocal of the period, and that's true. But you can also think of frequency as the number of cycles per unit. The interval from 0 to 1 contains 2 cycles of the function. That's 2 cycles per unit, so the frequency is 2. If you wanted to find the frequency by taking the reciprocal of the period, you would start by saying, okay, 2 periods equal 1 unit. Therefore, the period is 1/2 of a unit. Basically, divide both sides by 2. Then you say the frequency is the reciprocal of the period, therefore the frequency is 2. Number 4. The number of hours of daylight per day in a certain town can be modeled by a sinusoidal function that is graphed in the xy plane. Over the course of a year, the greatest number of hours of daylight per day is 14.5 hours, and the least number of hours of daylight per day is 7 hours. The line y equals d, where d is a constant, is the midline of the graph of the sinusoidal function. Which of the following is the best value for d? Assume that 1 year is 365 days. As I mentioned earlier in the video, the midline is the average of the max and min. In this case, the max is 14.5 and the min is 7, so the midline will be 14.5 plus 7 divided by 2. That turns out to be 10.75. So the answer is C. Number 5. Which of the following describes the relationship between the graphs of f of x equals cosine x and g of x equals sine x in the xy plane? Is the graph of g a horizontal translation of the graph of f? Is it a vertical translation? Is it a horizontal dilation or a vertical dilation? We have memorized that one period of the cosine function looks like this. Here's 2 periods of the cosine function. We've memorized that one period of the sine function looks like this. And here are 2 periods of the sine function. Notice how similar these 2 functions look. What kind of transformation to the cosine function would turn it into the sine function? What would happen if you took the cosine function and you shifted it 1/4 period to the right? The graph would now look like this. By the way, 1/4 of the period is pi over 2. Since we shifted the graph pi over 2 to the right, the equation is now x minus pi over 2. The phase shift and the c value are always opposites. Notice that shifting the graph of cosine pi over 2 to the right makes it equivalent to the sine function. In other words, g of x is a horizontal translation of f of x. So the answer to number 5 is A. Before I move on to number 6, let me demonstrate the concept one more time on Desmos because the graphs are so pretty. Here's the graph of sine x shown in red, and the graph of cosine will be shown in blue. Here they are together. Now I'm going to shift the graph of cosine pi over 2 to the right. Kabam! A perfect match. Number 6. The function f is given by f of x equals sine of x plus c, where c is a constant. Which of the following statements is true? First, a quick side lesson. An even function has y-axis symmetry, like this, or this. An odd function has rotational symmetry, with the origin as the center of rotation. That means if you take an odd function and you rotate it upside down, it's still going to look the same. Alright, that was a tiny bit off because my drawing wasn't perfect, but you get the idea. An odd function, if you imagine rotating it upside down, it's still going to look the same. Here are 2 periods of the cosine function. However, if you focus on one period of the cosine function that is centered around the y-axis, like this, you realize that the cosine function actually has y-axis symmetry. In other words, cosine x is an even function. Here are 2 periods of the sine function. But again, if you focus on one period of the sine function centered around the origin, you realize that the sine function has the rotational symmetry about the origin. If you rotated this image until it was upside down, it would still look the same. In other words, sine x is an odd function. This question is about the sine of x plus c, a horizontal translation or phase shift of the sine function, c units to the left, always the opposite of what you see. More specifically, the question is asking what kind of phase shift would it take to turn sine function into an even function. If the answer is A, it means that the sine function is already even and does not need a phase shift in order to be even. But we just saw that the sine function is odd, so the answer is definitely not A. What happens if we shift the sine function pi over 2 units to the left? We're going to take this function and move it 1/4 of a period to the left. This graph is now the sine of x plus pi over 2. If you focus on one period of this function centered around the y-axis, you realize that this does have y-axis symmetry. In other words, we are now looking at an even function. So the answer is B. If c equals pi over 2, that's a phase shift of negative pi over 2. And shifting the sine function pi over 2 units to the left turns it from an odd function into an even function. Just for fun, here it is again on Desmos. This is the graph of sine of x plus c, but right now c is equal to 0, so this is just the sine function. Notice that right now this is an odd function. If you kind of look at the middle, you can see how this portion has the rotational symmetry. If we turned this graph upside down, it would still look the same. Now we are going to use this slider to increase the value of c to pi over 2. That should shift this graph pi over 2 to the left. And now we see that the graph has even symmetry. The y-axis splits it right down the middle, and now the sine function is an even function. Hey guys, don't forget to like and subscribe, but also if you found this video helpful, there's a lot more where that came from. You can click the upper link, which will take you to the whole unit playlist, or you can click the lower link, which will take you to the next video in the playlist. See you there.